Alright, number 4 asks us to draw the Newman projection that represents the least stable conformation of 3,3-dimethylhexane, viewed along the 3 and 4 bond. Alright, so I'm going to start by just drawing out this 3,3-dimethylhexane, and really just the carbons. So that's the hexane, 3,3, and it wants to look along the 3,4, that is along this bond. Alright, so Newman projection. I have a big huge circle to represent the molecule, and I'm going to do the most stable at first. And the reason I'm doing that, I want to remember that on a Newman projection, when we're doing that standard zigzag, we always have an anti-orientation where the backbone or the biggest bulky things stay in a nice line. Alright, so if I'm going to call the one that's in front the 3 position, on the 3 position I have a methyl, and an ethyl. I'll put the ethyl straight down, and I'll make both the methyls here and here. On the 4, I have another ethyl, and I'm at least going to at first draw it in its most likely to be stable aspect, where we have that straight up and down anti-orientation. And then technically these other 2 locations must be hydrogens, so I'm going to put those there. Alright, and I do buy that this would be very stable. That ethyl at the top is close to those CH3s, but the only other place that gives us a staggered orientation would have that CH2, CH3 down over here, and then it's closer to this guy. So that is probably the most stable. But this one asks for me to get the least stable, so I'm gonna leave the front where it is. And I'm going to rotate it into an eclipsed form, but what I'm going to do is I'm going to rotate that CH2, CH3 so it overlaps with this one. So have it, that's a terrible straight line, have it in the back, and then here is overlapped with a hydrogen, and here is overlapped with hydrogen. And that would give me a very non-stable eclipsed form, and it has the 2 biggest groups eclipsed with each other.